All right, welcome to Build for Scale and Performance with Feature-Packed DynamoDB. My name is Robert McCauley. I'm a DynamoDB solutions architect specializing in NoSQL. I joined the company about 8 years ago as a relational developer, and since then I've come to really appreciate the unique properties of DynamoDB, and I'm so happy to talk about it with you today. Before we jump into DynamoDB, let's talk about this concept of purpose-built databases. We can think of it in the context of purpose-built trucks, right? We see 4 different types of truck here, but you could use a dump truck to carry materials across the country, to make deliveries as your personal recreational vehicle, but it might not be the best suited vehicle. And it's the same with databases. We've come to rely on the relational database over the last few decades. It does a lot of things well, but it may not be specialized for the types of applications we want today. Here's a look at the family of databases that we have at AWS. Starting on the left, we have relational database services like RDS and Amazon Aurora. And then the next 3 are the NoSQL family, the key value, wide column, and document, all very similar. I'll be talking about DynamoDB today. We also have Amazon Key Spaces if you have a Cassandra workload, and Amazon Document DB, which is perfect for MongoDB customers. It's API compatible. We also have in-memory databases like Amazon Elasticache, which lets you run managed Redis or Memcached. And then the newcomers on the block, the Graph, Time Series, and Ledger. We have Amazon Neptune, which is a fully managed graph database, perfect for things like social graphs, for fraud detection, and new applications that are hard to model with relational. We have Time Series, and this helps you to capture time data really quickly and do analysis on it. It's got tiered storage, so you can do your analysis and get rid of the data once you've gotten your answers. Really commonly used in factories or IoT environments and data centers as well. And then finally, we have Amazon QLDB, the Quantum Ledger database. And this is basically a database that provides cryptographic assurances so you can be sure who made any updates and they can't be changed or altered in any way. Great for regulated industries. All right, let's jump in. Why NoSQL? Well, let me tell you a little story. Back in 2004, in the holiday shopping season, Amazon itself was having a lot of pain and a lot of difficulties with relational databases. Right? We had armies of DBAs who were keeping the databases up and running, fixing problems and doing patching and restores and things like that. And they were also complaining that the databases were CPU bound. So instead of IO bound, the types of joins across these giant tables was pegging the CPU and causing a lot of problems there. We were already on the biggest boxes and we couldn't go any bigger. And in addition, the developers were complaining a little bit about having to do all the joins and having to understand all the relationships between tables. If you're building a shopping cart, you might want to just store a JSON document and not have to worry about the SQL layer underneath. So Dr. Werner Vogels and others put their heads together. They came out with the Dynamo white paper in 2007. And then in 2012, DynamoDB as a service was introduced about 9 years ago. And it addresses some of the problems we saw. So let's see why you might want to choose DynamoDB or NoSQL in general. If you're sitting down to develop a new application, maybe it's a new hot application that's going to sell and trade in rare JPEGs and GIFs, you might not know how many users are going to come to your application, where they're going to come from. Are they going to be local to your country or worldwide? It'd be hard to predict the data volumes. If you're storing these objects and storing the metadata about them, how much storage will that take? You'd have to do a lot of planning. You'd have to estimate the size of a server, perhaps, and then build a database, and hopefully you have it right and you haven't over-provisioned or under-provisioned. You probably want to have very good latency so your end users would have nice performance, no delays or waits, especially as traffic might suddenly surge with popularity or different events that you run. To scale, you'd want to have elasticity in your solution so that you can scale up and scale down. Maybe on nights and weekends when you're not using as much capacity, you'd like to not pay for that and bring your levels down. And of course, developers love that API access. You want it to be simple without a lot of custom drivers or proprietary connections or ports or protocols. You just want simple API access. And it might look like this. Take a JSON document or any document and just store it with put and get. And that's how DynamoDB started. It's grown to be a lot more. There's a lot of great features which we'll cover today, but in the beginning it was just put and get to a simple API. So why DynamoDB? Let's do a very quick tour of some of the great enterprise features that are available to you as a DynamoDB customer before we jump in to look at some of them in more depth. DynamoDB is a fully managed NoSQL database. And what that means is you don't have to set up any servers at all. You don't have to provision storage or anything. You just turn it on, you create a new table, it's an empty table, and you start adding data to it. You can think of it as a document store as well. If you have documents, you can store them up to 400 kilobytes in size for a single item or a single row. It could be a JSON document or an XML document or something like that. We have our versioning strategies as well. DynamoDB scales to any workload. And I mean that, at Prime Day, we see traffic in excess of 10 million requests per second to the DynamoDB API. And we're able to handle that. And we also have tables that are in excess of 1 trillion records. So we can scale up to the moon. It's very fast and consistent. As we'll learn, because of the way it's sharded and shared across all customers, across fleets of thousands and thousands of servers, it's very, very fast. There's no single server that's going to get overwhelmed and bogged down with extra traffic. It's part of the AWS cloud, so you have security as a primary consideration. We are integrated with IAM, so you can set up policies within IAM to provide read-only access or fine-grained security for rows and columns in the table. And as we'll see later on, we have an event-driven programming model, so you can create things similar to database triggers to process data as it happens in your table and take actions, take maybe alerts, or you do some roll-up aggregations, as we'll see. Some more features for you. If you're new to DynamoDB, check out the first two here, DynamoDB Local and the NoSQL Workbench for DynamoDB. These are tools you can put on your laptop to create everything you need to get started. DynamoDB Local simply is a small laptop version of DynamoDB on port 8000. And then you can use the NoSQL Workbench, this nice graphical tool to do modeling of DynamoDB. You can create tables, look at your keys and your indexes, and plug in some sample data and see how it fits. See how it looks as you aggregate by your partition key, for example. See what indexes enable you to do with queries. When you're ready, you can go ahead and press a button and deploy it to your real AWS account with all the sample data too. And then you can also perform operations in this tool like queries, deletes, inserts, everything, and see how that works. And also press a button to have it generate some code for you in Python, JavaScript, or Java. And the code is very robust, right? You have a whole bunch of error handling blocks which are useful. We also have on-demand backup and point-in-time recovery. And these enterprise features allow you as an administrator to press a button and do a backup at any time. And you don't have to worry about doing it at midnight, when the server is more idle. You can do it during the day if you like. It won't affect the performance for your end users in any way. Point-in-time recovery, as we'll learn, is a premium feature which protects your table for the last 35 days continuously. Protects against things like data corruption. So if you were to have a bug in your application and lose some data or modify data incorrectly, you could go back in time, maybe to yesterday at 3 p.m., and do a restore to a new table, which would be the table as it existed at that time. Everything in DynamoDB is encrypted at rest by default with a key managed by the KMS service. And you can also provide your own key, a CMK, customer managed key, which you provide, which will let you control the encryption of data. We have a time to live feature. As we'll see, this enables lifecycle policies where instead of paying to delete data that's no longer needed in your table, you can set up a flag and a timestamp essentially, at which time approximately data will be deleted for you at no extra charge. And that's great. It saves you the cost of doing the deletes manually. It also keeps the size of your tables and your item collections smaller, which has a lot of extra benefits. We have Amazon CloudWatch Contributor Insights, and this is a nice utility to ask CloudWatch to prepare some dashboards of what are the most popular keys in your access patterns. Occasionally with DynamoDB, if you have a lot of heat, a lot of reads and writes going to a single key, for example, you could get throttling exceptions which would probably need a retry. With CloudWatch Contributor Insights, you can get insight into what those patterns might be and understand how people are using your table. We also have the DynamoDB Accelerator, DAX, and this is a purpose-built cache that plugs right on top of DynamoDB. It provides, instead of millisecond, 10 single-digit millisecond latency, it provides microsecond latency. So useful for advertising customers, for example, to win auctions in microseconds, or just as a traditional cache, if you have a huge amount of read traffic to your table, this could alleviate some of that and handle some of the popular requests. And it's API compatible, so when you deploy DAX, you have very minimal code changes to point to the DAX service instead of pointing to the DynamoDB API directly. All right, more features. DynamoDB Streams. This is what I was talking about, the change logs or the event-driven programming. There's this service called the Streams service of DynamoDB. It's part of your table. You can turn on at any time. And with that, you can access it directly with some APIs, but more commonly, you'd attach a Lambda function and do processing, as we'll see later. We have global tables, which we're going to dive into. And with global tables, your availability goes from 4 nines to 5 nines, 99.999 SLA for availability, which is approximately 5 minutes of downtime per year. We have auto-scaling now. So with provision capacity, auto-scaling uses CloudWatch to bring your capacity levels up and down according to actual traffic to make your solution more elastic and to save costs when you don't need that much capacity. There's full transactions like we're used to with the relational world. So you can have ACID transactions with 25 items across multiple tables. They will either all succeed or all fail according to those ACID properties. And we also have adaptive capacity. This is sort of an internal feature where we can look at your access patterns. If you do have a lot of persistent hot traffic to a certain partition, a certain item collection, for example, and it grows to beyond a size or a velocity, we'll go ahead and use our adaptive capacity feature to cut that partition in half, basically move half your data to a new partition, effectively doubling the amount of storage and capacity for that set of data, and helping you as a customer avoid any throttling surprises that might happen. And this is all automatic that happens under the covers. All right, those are some of the features. We're going to dive deep a little bit now. Let's look at exactly how this works. So you work with tables, and behind the scenes, we have servers, of course. You don't see them or have to worry about them, but there are servers, and there are disks on those servers. And what we do is we create these virtual partitions. These are 10 gigabyte virtual storage nodes that manage your data. They never get beyond 10 gigabytes, right? And there could be dozens per server that are shared across multiple customers securely. But with a law of large numbers now, you can see how the traffic pattern is fanned out for any one customer that might have a table, that might have a lot of traffic suddenly. It can be handled. Your data is always replicated 3 ways across 3 availability zones for a very high availability and durability. Now, each partition has a max throughput of 1,000 write units per second, small writes per second, or 3,000 read units, 4 kilobyte reads per second. That's the maximum velocity before that adaptive capacity kicks in and starts splitting and alleviating heat. We also can store up to 10 gigabytes, as we saw, per partition before you take the adaptive capacity measures. All right, so let's look at some of the decisions you do have to make. Remember, there's no servers, there's no storage to worry about, but we do have some decisions to make about which capacity mode we want for our table as at different phases of our project. So when you create a table with DynamoDB, you'll get to the console and you'll simply create a table like this. Give it a table name, give it a primary key, which has to have a partition key, possibly a sort key for a composite primary key. And then on the bottom, you see how we have the provision capacity by default. And it might start off small with 5 reads per second and 5 writes per second, as you see here. And that may be fine if you have if you're just doing some low-level testing. That's perfectly fine, but you may need to grow as your traffic goes live and you have a lot more actual reads and writes. That's when you might turn on auto-scaling. And auto-scaling basically is the blue line you see here. It's the service uses CloudWatch traffic patterns and it adjusts your capacity levels up and down, both on the read and the write side. So it'll scale up more quickly than it'll scale down. If it sees traffic start to grow, it'll scale up. You have some control over this, right? You can say, maybe I want a 30% headroom by default in case I have any sudden spikes in traffic. You can set minimums and maximums and so forth. But it's a really nice way to recoup some savings, to bring your capacity levels down when you don't need as much capacity. Contrast that to a newer service, a newer offering we have called on-demand capacity mode. I sometimes hear this called the premium mode, right? It could be more expensive at steady state, but for new projects that are going live, it's perfect. Why is that? It's really aggressive with how it starts. It starts with about 4 times more capacity by default than a traditional provision mode table. It also scales up much more quickly, as we'll see. And the other benefit too is that when you scale down, it doesn't charge you anything at all. There's no minimum or minimum level of capacity, which is great. You know, if you're like me and you start up side projects and you forget about them for a month, you don't want to have a table, you know, running and possibly being billed and costing you money. So it's very serverless. You just simply pay for each request, read and write requests, a tiny fraction of a penny for each one of those, with no levels as such. So within on-demand, let's take a look at how it actually does this. On-demand, similar to auto-scaling, it looks at your levels of traffic, as you see here, maybe going up and down, growing, you're achieving new peaks maybe as your application goes live and gets more and more popular. And what it does is it does this partition splitting behind the scenes. It starts off with 4 partitions, or the ability to serve about 4,000 writes per second or 12,000 reads per second, or a combination of those two. And then it'll go ahead and increase that as it sees traffic come to the service that approaches that level. So it tries to keep your potential capacity always double what your previous peak was. So it very aggressively scales up. It's hard to overwhelm it, with sudden traffic surges, which is great, for holiday shopping seasons, for unexpected events, or maybe a viral post on Twitter that goes live, and suddenly you have thousands of users coming to your application all at once. All right, let's switch gears. Let's talk about global tables for a minute. Let's talk about the need for global tables. And I think that is the multi-region concept. Enterprises want to have disaster recovery strategies in place in case a region becomes unavailable, right? Regions don't typically disappear, but networks have problems, right? And a region might sort of appear to be gone for short periods of time occasionally, right? And if that happens, you don't want your users the application to stop and your users to be stuck. So companies would like to have a copy of their data or their table in a different region for that reason. Also, you might be required to do this. If you're in a regulated industry and you need to have a replication or replicas in different regions, then you have to figure out how to do this. The way it works, before we get into how it works, let's talk about how you might do this before global tables came along. And this is what people did a few years ago before we introduced the global tables feature. And it's similar to what you might do in the relational world as you're managing the idea of replicating changes across 2 regions. So the first thing you'd have to do is get some sort of a change log of all the changes to your table, as we see on the very bottom there where the stream is. DynamoDB Streams provides this. Then you'd have to build this replication service, which would look at all the changes and go ahead and ship those across the thousands of miles, maybe to another continent or another region, another agent running there, which will go ahead and receive those and apply those to the replica table in the second region. So that some customers did that. It's a little bit difficult, I think. One of the issues you'd have to resolve is conflict resolution. What are we going to do if somebody writes the same data to the same item at the exact same time, but they write different values? Who's going to win in that case? So there's a lot of edge cases to think about. It's also a lot of management in general. What if these replicators fail or have problems or bugs or are too slow and you need to increase their capacity, for example? So that's why Global Tables was invented and released. And here's how it works. Here's how we do it. You can basically take an existing table and turn it into a global table by adding a replica. Users will still see it as a normal, regular table. They're still going to point to it in whatever region they are with a table name. And they're going to do their normal writes to that table, reads and writes. And those are synchronous. So they're gonna, if you write to the main table and you do a strongly consistent read, you'll get strong consistency. Behind the scenes, DynamoDB, using our streams feature and global tables, will go ahead and asynchronously move that to the other replicas around the world. Right, and this will happen in usually, in my experience, between about a half second and 2 seconds before you'll see the data appear on the replica table that you put into the first table. For conflict resolution, we take a simple approach. We just say if we detect any kind of conflict in that 1 to 2 seconds between moving of the data, we're going to take the latest one and make that the winner and ignore the previous one. So we don't try to do any kind of strongly consistent, guaranteed consistency across regions. And there's a lot of theory behind that. There's Brewer's CAP theorem, which states, it's hard to have both high availability and high consistency at the same time. Right? We prioritize availability. If the network goes down for any reason or slows down between these regions, we don't want to bring the tables down and close shop just because we can't replicate for a little while. Let the replication queue build up. You can check stats in CloudWatch to see if that were to happen, pending replication count, and you can also see the actual latency that we measure. But we'll keep the two sides up. They'll still be available to your users serving traffic, and that's maybe what most customers would want anyway. We don't want to have downtime. We want to have copies of our data in different regions to serve those users. Some enhancements to global tables. We can easily add a replica table to a table that's not empty, that's full, which is a new feature as of about a year ago. And if you've used global tables in the past, we've really greatly increased the cost efficiency. So we don't need to do as many writes. So it's less expensive than before. All right, let's talk about a great customer that's using DynamoDB in a number of ways, Disney+. And you may have seen this if you're watching The Mandalorian or other popular Disney shows. There's some great talks on reInvent about all the different services, the ways they're using DynamoDB, for watch lists, for recommendation results, for caching lookups that you might do, and things like that. But I want to talk right now about the bookmark service. So, when you finish watching 4 or 5 seasons of The Mandalorian on a big binge watch, and you finally turn off the TV halfway through a season or an episode, you want to be able to come back and start up right where you left off. And so internally, there's a bookmark service, and it detects which region you're in, where you are in the world, using this telemetry service. It takes that information, which episode and where you were, and sends it through Amazon Kinesis data stream through a Lambda function. And eventually, it lands on a DynamoDB global table. And it's a perfect use case. It's a small bit of data. It has a key value sort of property to it, for this customer ID, for this episode, store this timestamp, this bookmark. And then the content API can pick that up very easily in the same way. When you come back tomorrow to finish watching, it can easily look up that bookmark, realize where you are, and start the video stream for you in the same place. So nice use of global tables. All right. Let's take a look at some newer features that were released at reInvent in the past year. And the first one to talk about is AWS Glue Elastic Views. And this is a feature that's still not quite released, but it's coming out very soon. It's got the idea of materialized views, where you can define data movement between different services, different data services in the AWS cloud, and will automatically copy and move data and project and materialize views between systems. You can learn more about it with the release notes and the blog posts as they come out. It uses something called Particule or Particle. It's a new extension to SQL that we've been using internally here for a long time. And it helps you do queries against structured data, semi-structured data, and nested data. So stay tuned for that. We also have an enhanced integration with Amazon Kinesis. You can plug directly into your table into Kinesis data streams and leverage some increased features, such as the ability for streams to hold your data for up to a year, and the ability to fan out beyond just the 2 concurrent readers that we have with our native DynamoDB streams. Finally, we have this export to Amazon S3 feature, which I'm excited to jump into next. Let's see how that works. So customers oftentimes, they want to either do a backup and get their hands on the backup to look at the data and analyze it, or they just want to take a copy of their data and maybe for an audit purpose or for an end of the year copier or something, and just be able to use the data in their own S3 bucket. So with this new feature, we can do this for you automatically. You don't need to set up any agents, any hosts or instances or ETL tools or anything. You simply turn on point-in-time recovery if it's not already there, and you're going to move your data into Amazon S3 using this service. You just create an export and watch it run. It takes about 2 minutes for small tables. It could take some time for a larger table. But within some time, you're going to look at your bucket and you're going to notice that the data has been copied there in a compressed JSON format. And from there, it's very easy to analyze it. We also have an ION format, which is a superset of JSON. With ION, we have even richer typing, so it can help to make clear, what's a date and what's a string and things like that. So some common patterns for this export to S3 feature are shown here. Once your data is in S3 in this format, you can easily start up Amazon Athena and do an SQL query against a virtual table within your bucket, which is nice. But you could also, turn on QuickSight. You could do Amazon SageMaker against this data. You could do an AWS Glue job to convert this format of data into Parquet format. And for Parquet, it'll be much more compressed and even faster for any kind of Athena analytical queries that you might be doing. All right, let's finish off. Let's talk about event processing with AWS Lambda triggers. How does this work exactly? So for every table, you can turn on streams for no charge. And that's the changelog of everything that's happening, all the writes to your table. Inserts, updates, and deletes. The change data will appear on the stream within a few milliseconds. And you can plug that into a Lambda function that you have using a Lambda trigger. So Lambda will be executed for every change, or maybe a batch of changes that you have every few minutes or every hour. You can process all that change data within Lambda typically, and then from there you can send it to anywhere you like. Some customers will go ahead and do increments for simple aggregations within DynamoDB. Maybe we want a count of how many customers have visited our site in the last hour, in the last day, in the last week, and we simply just bump up, increment an aggregation, a special record in our DynamoDB table, and now we have some aggregations available. But you could also send that data to Amazon Elasticsearch for a full-blown search experience. Or send it straight into Kinesis, perhaps through Lambda, and to those other services like we just discussed, S3, Athena, and so forth. But I think my favorite is using it to notify for certain events. Let's say you're a factory, and you want to be notified every time the temperature or the pressure or the humidity in a workflow goes beyond a certain threshold. With this, your Lambda function could have a little bit of logic in there to send an SNS message, like a text or an email, to a manager if it detects anomalies in your data that you want to look for. So you can do real-time processing with this pattern. All right, we only have a couple of minutes left. Let's quickly visit some strategies for migrating to DynamoDB, especially if you're a relational customer already. So let's say we have a schema with multiple tables in our SQL database, and we want to bring it into DynamoDB. We like to talk about single table design, and we stack the tables vertically. So you can think about maybe creating a view in your SQL environment, maybe a materialized view of all your data with union all to put those tables vertically on top of each other. Line up the columns so that there's a standard primary key. Line up any other attributes that you want to group by global secondary index. Write some sort of an ETL job to do put items or batch write items to move that into a new table. All right, with that, let's do a wrap up. So we have a bunch of resources for you. First of all, follow the DynamoDB Twitter feed, which is one of the most active AWS services on Twitter. And you'll get lots of great articles, blog posts, community content as well. You can go to our website to learn more. You can and see the documentation and the developer forums as well. And please learn about databases with training and certification courses. We're constantly coming out with new courses about how to use DynamoDB, how to program for it, how to model for it. We have a database certification exam that includes DynamoDB content. Visit aws.training/databases. All right, thank you for your attention and time today. My name is Rob McCauley again. You can follow me on Twitter at Rob McCauley if you like. I'm so happy to have you here, and please fill out the survey. We'd love to have your feedback and let us know what you think. Until next time, take care. Bye.